only this part is going to be recorded. So for the next maybe 20, 25 minutes, each one of our panelists is going to talk to you about their projects, their interests, themselves, a little bit about themselves, and so you can learn more about them and the products that they offer. So the first one that I'm going to introduce is precisely Dr. Jim Kuo from Mechanical Engineering. Jim, the floor is yours.
Let's me share screen again. I'll tell you a little bit myself. For MEs, for many of MEs, I'm sure I've taught you before, but there's lots of EEs, tech, and chemistry. So other people from different departments. So I'll just talk briefly about myself here. So I did all my education in mechanical engineering. I worked at very different companies in telecommunication, electronics assembly, automotive manufacturing, and as well as online education as well. So that's a little bit about me. Now I'll tell you what I do in terms of sustainability. So I'm mainly interested in kind of modeling, simulation, and optimization of thermal fluid systems. So anything that related to heat and flow, I'm fairly interested. And so for these things, so what I'm interested in is applications in renewable energy as well as thermal management. So here's some nice pictures. Well, maybe they're not nice, but there's some pictures of what I do. And so these are some of the things I'm working on. Now I'll jump to the next slide. And this is my last slide. So these are projects that I'm currently working on. The first project I'm working on is wind turbine modeling and experimentation. So this is probably my biggest interest. The second project I have is focused on flow and porous media and how to characterize the porous media. And so the next two projects I'm focused on thermal management of different type of things. The first one is solar PV modules. I know you're hearing the beeping in the background, but what I'm going to do, I'm going to power through this quickly, and then you can ignore me. And then the last project is thermal management of electronic devices. So that's another big project I'm working on. That's probably enough about me, and I'll pass the baton to somebody else.
Thank you, Jim. So thanks a lot for the information. The next panelist is Dr. Arezoo Khodayari from Civil Engineering. Arezoo.
Thank you. So good afternoon, everyone. And I'm Dr. Khodayari, faculty in Civil Engineering program. My education and my background is mainly in chemical engineering and environmental engineering, specifically pollution control. And as you may know, chemical engineering is the knowledge of chemistry and engineering to design, produce, and transform and transfer new product, material, energy efficiently. And when it applies to environment and when it's for the purpose of reducing pollution from water, soil, and air, it becomes environmental engineering. So it's very important because our world is becoming more interdisciplinary nowadays. So if you have interest in any of these areas, you can maybe discuss with me about the opportunity to join our research group. My research lab, which is Environmental Sustainability and Pollution Control, ESPC Research Lab, has various projects in the area of sustainability. I'm going to introduce few to you today, but you can check our website to learn more about the various research projects that we have. My area of expertise is mainly developing sustainable engineering solutions to reduce air and water pollution. We can do anywhere from experimental work to modeling work. We can predict how the pollution is going to be in certain area. We can develop certain technology to reduce pollution and control pollution, both for water and air. But again, mainly my expertise and interest is in air quality, but I do water research as well, and also integrated environmental impact assessment. meaning that we are going to do a full circle analysis, net analysis of environmental impact of various processes and energy options. I'm going to give you a few examples of different research projects that we currently work on. One is developing a new air quality metric to evaluate air pollution in Los Angeles. You know, we have air quality index that you may be familiar with that can tell us how bad air quality is in certain area. We are working to develop a new metric that not only can tell us about the magnitude of air pollution, but how it can be air pollution can be transported between different regions. Another project is developing some kind of technology for removing nitrate and phosphate from wastewater, as nitrate and phosphate are very important air pollutants. Another project is transforming food waste into energy for urban sustainability. So basically we are using anaerobic digestion of food waste in order to produce methane to be used as a source of energy. Also, another project is optimization of hydrogen production schedule at our hydrogen station. Dr. Blekhman, who is attending our session today, is the technical director of hydrogen station. So we are working with them in order to develop an algorithm that can be used to optimize production of hydrogen so that the production cost can be minimized. And also another project that we just basically kind of concluded that project was developing a sustainability tool for Cal State LA. So this sustainability tool is an energy dashboard that can show us how energy is utilized on campus and how much is the associated greenhouse gas emission and how we can minimize the environmental impact of various energy options on campus. If you want to learn more about our research group or be in contact with me, please website my faculty page at university webpage or our research group webpage, ESPC Research Group. Thank you.
Thank you, Arezoo. Next is Dr. Mehran Mazari from Civil Engineering. Mehran, please.
Sure, thank you. Thanks everyone, and welcome to today's session. Just very quickly, I have only 4 slides. My main focus area is sustainable transportation infrastructure. It involves all sorts of and all modes of transportation, including the transportation infrastructure materials, all the way to the actual transportation systems and all the modes of transportation. So if you're interested in any topic remotely related to transportation, we can definitely discuss that. One example is use of pavements and how we can use the urban heat island from the energy that's coming from, or the heat coming from, reflected from the streets in our urban areas. Some of the works that we are doing, we have developed a pervious concrete that is impermeable to water. And also we have started to printing concrete with different types of materials. If you're interested in our group, we have a very diverse group of students. We usually have visiting students from other countries. We had 2 students from France. 2 years ago, we had a student from UC Berkeley visiting us for 2 summer research projects, and also we are a multidisciplinary group. We have students from mechanical engineering and sometimes computer science joining us. So if you're interested in our research group, just simply scan this code with your phone, and you should be able to see more information on our website. And just to mention that we have paid student positions, research assistantship positions, stipend, as well as transportation fellowships that they can get up to $10,000 in stipend and travel abroad for any transportation related project. That's it for me. Feel free to connect with me on LinkedIn, Twitter, and if you're on Discord, I've already created a server on Discord. So that's it for me. Thank you.
Thank you, Mehran. I appreciate it. Next is Dr. David Blekhman from Technology. David?
Yep. Okay. Hello, everyone. My name is David Blekhman. I'm a professor in technology. Originally, I'm from Russia, graduated from Polytechnic University there. And I was visiting them last year, so I've celebrated 100 years of the college. And that's my professor of physics. It's been almost 30 years. So he's around 70 years old, and he was singing for us. So that's kind of a celebration. And then I was in Buffalo, in New York, and below is a list of various positions I have with the college and different projects. So my specialty is renewable energy, hydrogen technologies, clean transportation. Here's a research project Tiran Gekusyan did. We measured the efficiency of our photovoltaic system on the roof. Then we ran efficiency for the electrolyzer, charged hydrogen, and he was driving a hydrogen racer we built for a shell competition before. And so the efficiency overall comes out pretty low, but that it actually identified certain pathways that need further improvement. The vehicle itself is 50% efficient, but electrolysis, at least the unit we have, is half efficient as modern electrolyzers are, 60%, and the solar systems need to be improved. But that's a cool project technology student was working on. Also, another project was EcoCar. You guys probably have seen it and have heard. We started with a regular vehicle and did a full conversion into a plug-in hybrid vehicle. Below, you can see a police-themed car. We found a lot of benefits of hybrid vehicles for police application. Just not many of them are on the market. And here's the team receiving award for public outreach, that the program and campaign we conducted over several years, educating public on clean transportation. Of course, as Dr. Khodayari introduced, I'm a technical director for the hydrogen station. We built it in 2010, 2011. Then we had a grand opening, and like any industrial plant that makes its own hydrogen and then fuels cars with hydrogen, we had failures, but failures like equipment breaks and things don't work and we need to fix, and here's hydrogen leaking. So students did industrial research on the reliability of various components where failure, and how many years it took before the component failed. Another exciting project we have with the hydrogen station, we had vehicles available for students as a shared mobility. The program was called Wave Car. And also, we really like to bring students and people to learn about hydrogen. So that's the picture on the right bottom. And I love that picture because kids came in their lab coats. So that was a lot of fun. And the last one I would like to show with you, we have our solar system. So we really take it, the entire scope from sun to hydrogen to transportation. And in addition, I'm not only hydrogen guy, I was also instrumental in helping campus to establish robust electrical vehicle charging infrastructure. And just last year, we installed, this fall, actually, past fall. Yeah, post fall. We installed 6 fast chargers on campus, so that was a big accomplishment. So we can charge a pretty big fleet of vehicles, and on campus it's free for our students and staff. So get your clean transportation ready. And the governor's recent announcement that he wants all of the sales to be zero emission vehicles by 2035. So I hope you guys will reach out if you need it, if you want to do research in clean transportation and related technologies. And now it's going all the way back into the renewable world of wind power and solar. So it's all interconnected. And thank you very much for the opportunity to speak to you today.
Thank you, David. I appreciate it. Next in line is Dr. Sonia Lopez from the Department of oh, excuse me, is and this I had to do this to my friend Gustavo. Next in line, sorry, is Professor Gustavo Mendez, and he is from the Department of Civil Engineering, and of course, please go ahead, Gustavo. We cannot hear you.
Oh, yes. Hello. Can you guys hear me? Yes.
Yes. Yes. Go ahead, please.
So I'm glad to see so many of you here. I was going back when I was preparing my slides this morning to when I applied to grad school, and at the time that I finished my bachelor's, I was ready to quit school forever. You know, I told myself I'll never go back to school again because I was so tired of school. But I remember that when I joined my master's program and I started developing and working on research, that was when I truly developed passion for engineering, and I truly started to understand why we learned what we learned. So I think graduate school is quite important, you know, and the skills that you develop through research can be really helpful in your careers. So I did my PhD in North Carolina, and I came to Cal State LA in 2009. And I think in principle, my goal is to seek sustainable, holistic solutions for civil engineering problems. And we have lots of civil engineering problems, right? You can think about our urban society in terms of transportation, in terms of water availability, in terms of pollution. I have an example here this is the LA River back when they had the flood in 1930s. And this is the engineering solution that we have right now in place, which is a concrete line channel. But LA is now moving towards a more holistic solution, which is more environmentally friendly. It's also more, it looks nicer, right? And it's better for the population. So looking for these types of solutions or something that interests me. My area is the intersection of geotechnical engineering, which is soil mechanics, environmental engineering, groundwater engineering, which we call geoenvironmental engineering. And my focus area has been mainly on groundwater. As in urban settings, we have lots of contamination sources for groundwater. And so the contaminants leak and go into groundwater. And why is that important? Well, in California, about 40% of the water comes from groundwater. And in fact, 85% of Californians depend on groundwater as a source of water supply. More specifically, I work on understanding how water flow through soils in general or other porous medias using steady state centrifugation. So what we do, we put the soil sample inside the centrifuge and we pump water through it so we can simulate the processes that happen in the environment, but in a much faster rate. So things that would happen years to happen in the environment, we can test over weeks. So I work with saturated and unsaturated soils in here. And here are some of the past projects and applications in terms of, I have here contaminant transport. So when contaminants hit the groundwater, we want to understand how they move through groundwater, and also understand hydrological processes that affect groundwater recharge. As I mentioned, groundwater is an important source of water. We want to be recharging the groundwater. I've been working on soil erosion and a little bit of slope stability. This is a project that I'm involved on down here on the left side in Brazil, in terms of using bioengineering techniques, but always from the perspective of understanding how the water moves through soils. There is, we did some research on recycling fly ash. Fly ash is a subproduct of combustion, right? We use a lot of thermal energy, and we have lots of fly ash mountains around the country, and trying to figure out how we can use fly ash. And we are now entering this new research area. It's in collaboration with Dr. Lopez. She may talk a little bit more about that. where we are looking at how wildfires are affecting the hydraulic properties of soils and how that is affecting the hydrology of the area. So I think this is pretty much what I have.
Thank you, Gustavo. I appreciate it. Next is Dr. Sonia Lopez, also from the Department of Civil Engineering. Sonia?
Getting ready here.
Great.
All right. So when I was figuring out what to talk about today, I always start with kind of these general questions when I'm introducing myself, right? Who am I? Where do I come from? And what do I like to do? And that kind of relates always back to water resources engineering and sustainability in water resources engineering. So first off, who am I? My name is Sonia Lopez. I earned my bachelor's, master's, and PhD from UCLA in hydrology and water resources. I have a few minors that I like to integrate in my classes, so environmental engineering, statistics, and geography and environmental studies. I'm also the faculty advisor for SHIP at Cal State LA. I was really heavily involved in SHIP when I actually became a graduate student, and it again, is how I kind of develop a lot of my projects, because I try to make sure that I consider some of my industry partners. I teach fluid mechanics and water resources, which are the lower level classes. And I also teach hydrology, hydraulics, statistical hydrology, and open channel hydraulics, if any of those coursework might be interesting to you. Where do I come from? So I was born and raised in Gardena, California. So it's where the 405, the 91, and the 110 intersect. It's the land of the freeways. So LA is my home, and I have been trying my whole life, right, to protect it. And I'm also a first generation college graduate. So I'm hardworking and I'm very goal oriented. I'm also the youngest of 4 and only female child. Okay, how does that relate back to sustainability? And I always think of my upbringing with my parents, right? When my mom always said, waste not, want not, right? Always use all the materials that are available to you. And my dad always said, he was born and raised in Mexico City specifically, and he was very, very particular about taking very fast showers and never, ever leaving the water running. And he would say, you have 12 minutes to shower before I shut the water off. And so from a very young age, I was very committed to conserving water, being considerate of how much water I used, and sharing that knowledge with my friends. So sustainability and protecting water resources in Los Angeles is who I am. It's a part of who I am. So what do I like to do? So this is kind of what I always introduce as my research spectrum. I kind of like to do a lot of things. I focus on urban areas, how green infrastructure can integrate into urban areas, how climate variability is going to impact us down the line. And I use a series of tools. I use conceptually based modeling, remote sensing, and physically based modeling. And so this is kind of like, if you ever had any interest in doing any of this type of work, this is where we can fall in. Specifically, these are the projects that I have going on. I have a project on urban sustainability. This is actually with Dr. Mazari, where we were talking about focusing on urban infrastructure and looking at the strength of pavements when we're talking about floods and things like that, and how flooding and inundation affects the strength of pavements. I also have a project on hydrologic sustainability, where we're looking at integrating green infrastructures into watersheds to look at the short-term and long-term impacts. The second project involved the senior design cohort, where we actually developed a decentralized treatment facility, and we did some pretty cool modeling to show how that treatment facility will impact our groundwater resources. I also have a project on large scale hydrology, where we're looking at NASA products and developing an empirical model to relate precipitation, inundation, soil parameters with global flooding. So that's something that I'm working on. And I'm always thinking about climate change and how climate change is going to impact our water resources. So Dr. Menezes has mentioned we're working together on a wildfire project. So that's project I'm also integrating with climate change and predicting wildfire occurrence and intensity, as well as the changes to the hydrologic components, evapotranspiration, soil storage, overland flow. All of these things are important because they all relate to how much water we have, how clean and how safe is it to drink, and how much of that is going to be available to us in the future. So we can't just think about the here and now, we have to think about our future down the line. So if any of these projects seemed at all interesting to you, I have my email address. Please feel free to email me. I wish I could say stop by my office, but I don't know when that's going to be feasible. I also have my faculty webpage that has some information about my students, where they are, and their projects. I do highlight some skills because that's usually a question that I get is, what are you looking for in a student? And I would say that if you have willingness to apply computing language, that's a start, because most of the projects that I work on do process quite a bit of large data sets, and doing that in Excel will be a pain. But that doesn't mean that you have to walk into my lab being a computing expert, but you have to be willing to take on that training. So that's it for me.
Great, thank you, Sonia. Next, and actually last, is myself. I'll try to go fast because students, I think, want to ask questions, and therefore, let me quickly share my screen. Here, share, and then, okay. Let's see. Okay, there you go. Okay, so as I mentioned earlier, my name is Arturo Pachecho-Vega. I am a full professor in the Department of Mechanical Engineering. My education is in mechanical and in electrical engineering. And I studied back in Mexico, along with my first master's in mechanical design, and then went on to pursue a PhD, being sponsored by a Fulbright fellowship. After I finished, then I stayed at the University of Notre Dame as a visiting faculty, and then went back to Mexico to the University of San Luis Potosí, where I became an associate professor in the Department of Chemical Engineering, actually. And then back in 2008, came back to the US and joined Cal State LA. Currently, I am the director of the CREST Center for Energy and Sustainability, and it's a research center that is comprised by more than 20 faculty members, and currently we have about 25 students and student fellows, every one of them with a fellowship to pursue their careers. Earlier in my career, I was actually, after I finished my undergraduate education, I was hired by Cemex as a project engineer. So I have some perspective from the industry. But as Professor Menezes mentioned earlier, once I started doing research, I became extremely interested in that, and just learning about new things excites me a lot. It's really cool, and I think contributing to developing science and technology, I think is great. So my area of expertise is in fluid mechanics and heat transfer, thermal and fluid sciences, and I have a huge amount of different interests. And I just dropped on the PowerPoint a few simulation and control of thermal systems in general, but particularly of heat exchangers that I use in heat ventilating and air conditioning systems, which are very, very important in your houses, for instance, to have a nice temperature inside your house. Self-computing technologies and artificial intelligence is another area that I am interested in, and I have worked substantially on that. Optimization, data analysis, analytical and numerical methods, and then fluid flow and heat transfer at the macro scale and then the micro scale. So basically at the very big scale and also at the very, very small scale, let's say to cool the chips in your computer, you need an important element, and these are heat sinks or microchannels that we call them that. So here, what I am showing to you guys is a set of different projects that are open, but I have been working on with different students at Cal State LA, and are open because every time you answer a question, there are more questions that come up, and some of these things will be, let's say, studied analytically, or will be studied with the development of mathematical models and then numerical methods, or they will be studied experimentally. For instance, the one here at the middle, the modeling and simulation, is just to establish the level at which a model can, a mathematical model that you develop can be accurate, and how accurate it can be. The one on the bottom left, heat transfer enhancement in microchannels, is just a way to solve problems in small devices, computers, for instance. And we are proposing the development of these microchannels, and the topology of the microchannel can be changed, and how this topology affects the mixing and then the heat transfer enhancement. The other thing that we have done, and it's still open to whoever wants to work with these types of projects, is the modeling of heat exchangers using artificial intelligence, in this case, artificial neural networks. And what I'm showing here is a very complex system, which is a compact heat exchanger. Is a device using HVAC systems. Then the model of it via artificial neural networks, and then the accuracy of the result that you can obtain from the data, and then the training of the artificial neural network for different applications. In this case, the performance prediction of these type of systems. And then if you are interested in the development and the stability of systems, you have these types of systems, which are natural convection loops. And these systems could be stable or unstable, let's say, and these systems could lead to some extent to chaos. And what I'm showing in the right-hand side is basically an example of how this system can lead to unpredictable solutions. Let's put it that way. These are important systems because they can be used, these natural convection loops can be used as in nuclear reactors to cool the core of the reactor. So they don't need external pumps. Then at the macro scale level, I have an interest of studying, and I have actually studied some of these numerically, geophysical flows, the mixing that you have here, a hurricane, you can have a twister, you can have mixing in the ocean, and we have developed measures of this mixing via numerical methods. This is an open problem too, and if you are interested, you can always contact me on this. Another important problem is in microfluidic fuel cells, and these systems are extremely important, as Dr. Blekhman mentioned earlier in his presentation. We have actually cars that are run by fuel cells. So understanding how fuel cells work is very important, and also designing fuel cells under different conditions of operation. And finally, I'm going to talk about one of the new areas that I have started to work on, which is the control of multi-room buildings. And we have developed, using the senior design project, we developed this test bed or this experimental facility to to essentially build controllers, smart controllers, in this case, fuzzy logic-based controllers, in order to control the temperature in the rooms while we want to minimize the energy expenditure. And this is extremely important because we need to leave reliance on fossil fuels and go into energy efficiency and into other alternative energy sources if we want to have a sustainable life. And finally, I would like to mention that this is the right bottom part of my presentation here. You have just a sample of the students that have worked on these projects and where they are. For instance, Eric is currently an Northrop Grumman, Janet, Angela. Well, Janet just finished her PhD at the University of California, Riverside. Angela finished her PhD at the University of Michigan and is currently a postdoc at Lawrence Livermore National Lab. Tobias Hummel, who worked on the natural convection loop, got his PhD from the Technical University of Munich in Germany. Hector Gomez is currently at UC Merced in his PhD. Joshua Baltazar, who worked on this control of multi-room building test beds, he is currently at the University of Rochester. Usama Tohib is a part-time instructor in the Department of Mechanical Engineering. He worked in fuel cells, and he is also in the industry of HVAC. And then Meline and Arsine, both sisters, they were both my students, Arsine in the senior design project, and then Meline in this project of geophysical flows. They both work up in Washington State for a company that handles nuclear residual. So you see that these projects open doors for students. So if you are interested in these projects, please contact me and I'll be happy to talk to you about them. Thank you. So I think that this part, let me see, okay, 1 second. We have come to end of the presentations. I'm going to stop the recording. 1 second.